Thank you for joining today's webinar, How CityBots Will Revolutionize Inner City Mobility. Today's webinar is going to be recorded. It is going to be available on replay. We would like to make it interactive using Slido. In your Slido, you will also find useful links from frequently asked questions to videos. At any time, you can drop your questions in the chat function directly here. We will answer the questions at the end of the webinar. Now, please let me hand over to Rafael Fietzek, our host.
Yeah, hello and welcome to our webinar, How CityBots Will Revolutionize Inner City Mobility. I'm Rafael Fietzek, I'm Managing Director of COMPREDICT, and I'm pleased to welcome Jörg Hölig as a guest here in our webinar.
Yes, hello, Rafael. Thank you for the invitation. And my name is Jörg Hölig. I am the head of the Competence Center for Safe Mobility within the EDAG Group. And we are cooperating COMPREDICT and EDAG in the project called Campus FreeCity, which we are going to feature today. And I'm happy to explain a bit about the idea behind and about the project content.
All right, great. Yeah. So as you mentioned, Campus FreeCity is the project we're talking about. It's an innovative project about a connected fleet of autonomous robotic vehicles and the whole ecosystem around it. That's the important thing, namely the control system and the online booking. There will be a living lab installed around the stadium of Eintracht Frankfurt, where the CityBots will drive around and do various tasks. Jörg, can you tell us a few words about the vision behind this project?
Yeah, sure I can. Basically, our engineers and our creative heads felt challenged by the shortcomings of today's urban traffic. So it's from time to time it's a pretty annoying experience. So the roads are crowded. You've got gridlocks all around, too many vehicles on the road, very low average velocity, emissions, noise, and a large demand of city space, of surface space, which needs to be dedicated to traffic simply. And we had a very creative and fruitful process. And at the end of this, we came up with the idea of CityBot, which I would like to explain using a video. Maybe you can please start the video so that I can explain our vision. So we suggest to replace all powered vehicles in the city by a fleet of automated modular vehicles, such as this one here, which is performing municipal work at the moment. And these CityBot vehicles transport people, carry goods, or perform work for the city administration. And they serve the people. So they are like assistive to the city citizens. And as you can see, we will have much less vehicles on the road if this has come into reality. The vehicles are moving permanently, fluently, and they also sense pedestrian crossing their way, slow down, and so we avoid accidents by this. You can see here the included business cases. So the dream must, of course, be affordable. It must be profitable to run such a system. And all these services, moving people, moving goods, performing work, will be paid automatically and safely. We conclude all the information about the CityBots, about major city events, about orders and billing in one operation center. In this operation center, the back-end computer basically is also aware of major events in the city, such as football matches or concerts. So there will be a large number of passengers be expectable to be transported, and the city system is aware of that in advance. What you can see here is a former parking house, which has been transformed into a CityBot workshop and charging, refueling station. And it's also allowing to exchange the use case module, which make these CityBot vehicles very versatile. So you can see the excellent maneuverability. They can move laterally to have the shortest way to the next module, exchange the module for the next order to be fulfilled, and move out and perform service to the citizens and earn the money for the owner. So again, a symbol like a coin lifting up. People have arrived, the ride has been paid automatically, and the people can go on. This is just addressing an emotional aspect and of course supporting acceptance of such a system. The vehicles are very defensively programmed, and they always give people, other participants in the traffic, the right of way. So concluding, we think urban traffic in the future will just be a logistic challenge. There will be a constant flow of vehicles. So by this, by this coordination, we avoid gridlocks, have a fluent traffic, less vehicles, and all transportation of people, of goods, and working jobs will be done by much less numbers of vehicles. That's the vision behind.
All right, yeah, this sounds great. Can you do a little bit more of a deep dive about the holistic approach?
Yes. We thought having vehicles electrified, vehicles automated, vehicles connected, etc. Is fine, but it's isolated. So if we combine all these technologies vehicle-wise, if we network the vehicle fleet with an order and payment system, we get a holistic approach which is covering all the needs, knows about all the orders and transportation demands, and addresses it to appropriately configured vehicles which are in the vicinity of the people who need the service to be accomplished. And that gives such a system a huge potential of optimization, of cost savings, and of good quality of service.
All right, yeah. So part of this holistic approach will be, of course, also a vehicle management platform, which is optimized for fleet operation and management. We will go into more detail on that topic later. But right now, can you tell us how this project was born? How was the idea generated? Yeah, so some more details on that.
Yes, I can do. We started back in 2019 at the Frankfurt Motor Show. We showcased the stationary people mover, a VIP shuttle, a two-seater, which is basically just the representation of the vehicles associated with that ecosystem. And that was the first time we world premiered our idea, and that has been followed by 2020, where we performed over a period of several months our EDAG Tech Summit series of events. And in these events, we showcased for the first time a functional working prototype. We call it the AI, Artificial Intelligence prototype, a working device which comes in the setup of road cleaning device, grabbing, identifying, addressing paper balls laying around, grabbing them and removing them. And now it was time, after having showcased two vehicles, basically to demonstrate and to set up for the first time the whole ecosystem, to demonstrate it and to make it visible.
All right, yeah, perfect. That's why we are basically together in the project with other partners as well. There's a whole consortium of partners. Each partner has a certain role in the project. For instance, the home GmbH, they're the coordinator. They do research on ethical, legal, and social implications of the whole CityBots concept. We, as COMPREDICT, we are responsible for vehicle component monitoring with virtual sensors. EDAG, of course, they're the main partner here. They are responsible for the complete ecosystem of the CityBots. We have also Eintracht Tech as a partner. They provide the infrastructure, so the CityBots will be driving around the stadium and do different use cases there, as I mentioned before. Also, T-Systems is in the project. They're responsible for the teleoperation and the technical surveillance. Dekra Automotive, they will do research about the derivation of future homologation requirements for modular autonomous vehicles. The main topic there is functional safety. We have also 2 universities working on the project. First, there's the Fulda University of Applied Sciences. They will do the human-machine interface, cybersecurity, AI implementations, and things like that. And then there is the Technical University of Darmstadt. They will do the reliability and drivetrain energy optimization, and they will also calculate the sustainability potential. So this project is really a big project. It's technically very complex and compromises a lot of challenges, and which have to be addressed in a real-life demonstrator, which will be driving around the stadium in Frankfurt, which is really great.
Yeah, there are really a lot of challenges involved. So that is from our part of project contribution. We address vehicle challenges such as really complex technologies such as AI, assisted functions, new kind of powertrain. We will have to network the vehicles into operation center, which addresses or which requires to address a low latency communication along with cyber secure setup of the whole system. But also, that is last but not least, we have to address acceptance and ethical, legal, social implications. So there is not just a technical job to be done, but it's also to convince, to explain people what is inside this offer we are making to the city.
Yeah. All right. Okay. I think we can have a look at the timescale of the project. Yes. Maybe you can tell us a couple of words about that.
Yeah, we had to cut down the project into 2 major phases. These are indicated by the 20 months duration in phase 1 and a 9 months duration in phase 2. Basically, we will use the first phase to make concept and design and make the vehicles and the use case modules. We have to set up the vehicle Car2X network. We have to program front-end apps for the users to put their orders into the system, and all that has to be developed, implemented, tested, and then integrated. And once all this is up and running, including insurance, including technical permission to run the lab, then we are at the end of phase 1 and ready to go. And we are all very keen and happy and looking forward to start this lab phase, which will cover 9 months, probably 4 days per week, laboratory drive activities to research, to collect experience, and to gain all the information we are striving for.
All right. Yeah, perfect. So it sounds really interesting. So maybe next week we can take a closer look at COMPREDICT's role in the whole project. Yes. So as I said before, we will be mainly responsible for predictive maintenance. There are 2 parts to it. First of all, lifetime prediction of components, and then also fault prediction. This means if there is some kind of exception with this fault prediction, we plan to enable predictive maintenance, and we will also gather data to determine further R&D improvements. So how can we make components better in the next generation of vehicles? And this is all based on our virtual sensors.
Yes, and that is very helpful for us because we've designed the vehicles, we did the CAD work, the testing, we've set up the vehicles, and then we are of course keen on learning how do these vehicles perform, how much are the modules and the functional parts under load. Yeah. And your data will give us a very valuable feedback to validate our design.
Yeah. So there are a lot of use cases with these vehicles. They are very, very modular, and for us it's important to gather all the loads with the virtual sensors, and in order to understand better what a virtual sensor is, let me start with a basic explanation of virtual sensors. Yeah, because when most people think of sensors, they think of a piece of hardware that measures a certain physical quantity. We think of sensors a little bit different. There are already a lot of hardware sensors in a vehicle and in a CityBot, of course, as well. And we use the data of these hardware sensors as an input to our virtual sensors. So virtual sensors use already existing in-vehicle data to generate new insights with AI-based models. With our virtual sensors, we are able to provide detailed condition monitoring of various vehicle components. For instance, we are able to measure the remaining thickness of the tire tread, thickness of brake pads and brake discs, the current state of health of the high voltage battery, and much more. In this project, we will provide virtual sensors for condition monitoring of components, which will allow fleet operators to perform optimized predictive maintenance.
Yes, and that is basically the feature we are most interested in. So in the first step, it's not just validating the current design. It's also about learning to know when components or single parts may fail, and to know this in advance is basically an advantage for a later fleet operator. So you can schedule maintenance ahead of a component failure, and you remain in a planned regime of operating the system. And this can only be done if you've got proper instrumented vehicles and a good data analysis. And in the second step, if you just think further, coming from predictive maintenance, one can imagine this data also helps designing the next generation of parts of the whole product. And then we are talking about closed loop engineering, taking the data to have an improved design for the next generation.
Yeah. Let me deep dive on that a little bit. Yeah, we use our virtual sensors to collect data on how the vehicle is used. Yeah, and this is, as I said before, especially interesting with the CityBots. Yeah, and based on the collected data from the virtual sensors during vehicle operation, we can also generate usage and load profiles. Yeah, so we are able to tell EDAG which vehicle components are subject to what mechanical stresses based on existing in-vehicle data. And this information can be then used to identify under or over-designed components. For instance, if under real driving conditions, our virtual sensors measure that a certain component has an average to endure more force or torque than it was originally designed for, this component can be made stronger. So if it's under-designed, or on the other hand, if our virtual sensors measure that certain components had to endure less forces than originally planned, these components can be made lighter. And the result is a vehicle that is optimally designed for the use case. Maybe one more thing to add. Yeah, we have already many virtual sensors implemented in our Tesla Model 3 demo vehicle, which you can see here. If someone from the audience is interested in experiencing our virtual sensors live on a test track, please contact Katrin or me after this webinar.
Yeah, that's very cool. And we are really interested in what we learn about our prototypes. That is definitely a very interesting story then. And we will learn a lot about how to design the next prototypes in the series of CityBot, which are supposed to be following.
This is basically our great vision for the virtual sensors. Yeah, establish a continuous improvement process for vehicle development to get really the best vehicle for the use case.
Yeah, very cool. So that's really databases and a tool we've been waiting for quite a while, and that is really encouraging to see it's coming up and becoming usable and available.
All right, perfect. Yeah, but let's go back to CityBots. Can you give us an outlook? Where are we heading? What is planned for the future? When we will see CityBots on public roads? This is the question everybody wants to know, I guess.
Okay, so when thinking about how to overcome today's urban traffic shortcomings, we thought about combining upcoming and existing technologies. So it's no voodoo, it's just combining things. It's complex enough, but it's feasible. And we think it's feasible by 2030 to enter the inner city of a major city as we know it as of today. And the challenge is a big one, of course. Everyone knows about implementing automated driving in the inner city is really a challenge, but there are many specialists and OEMs working on it, and we are confident in technology will be available early enough to go into the city. But it's so complex that we cut it down into 2 intermediate steps before entering the city. And we call these intermediate steps step number 1, step number 2. And currently we are entering the project along with COMPREDICT, with Holm, with T-Systems and the universities. The project we call Campus FreeCity. We enter a living lab where we can, for the first time, establish, set up, and make run the ecosystem and play with it and collect information. That is our step 1, which you can find here in this circle in the center of the slide. The next step, step number 2, is supposed to be to have the CityBot fleet in a productive environment, not yet in the city, but in an intermediate level of complexity. And that will be the step when the CityBot fleet for the first time has to deliver its service, and people are depending on its working and delivering. And our idea is to go either into, say, a logistics hub where you have external, internal goods to be moved, loading, unloading of vehicles, and to empty and to fill the shelves, or we go to the airport and do all services there in terms of people transport, of goods transport, and of garbage removal, fueling the planes, stuff like that. Everything that is being done by powered vehicles as of today. And if you've got time, I do not know if you've got time, we've got a video prepared lasting almost 1 minute, which is visualizing our vision of how such an airport scenario could look like if the jobs are performed by a fleet of such CityBot vehicles, if you like.
All right, perfect.
Yes, okay. So you can see that the very heterogeneous vehicle fleet which is out there today can be replaced by a fleet of identical tractor modules which carry different exchangeable use case modules. And so these vehicles with their modularity are able to move the people, transport the goods, guide the planes to their starting slots, whatever you like. And you again see from time to time this coin symbol lifting up from a vehicle, which is indicating the included business cases. So the transportation services or working services need to be paid for, and that's all done automatically and securely by means of cyber-secure micropayments. So you can consider our project we are starting right now, and also this airport scenario as ecosystems which are similar to a large city center, but at a smaller scale with less complexity. And so it's for us engineers a great playground, if you like, to research and to collect experience.
Yeah, this looks really fascinating, and we are very, very happy to be part of that that road to bring CityBots to in use. Let me put it this way. Yeah.
Mm-hmm.
I think we have some questions from the audience. Is that right, Katrin?
Yes. The first question was, how many CityBots would be required in a city like Frankfurt? Can you answer this?
I can estimate it. Yes, interesting question. We think one of the key success factors to have a more pleasant urban traffic in the future compared to today is to have less vehicles on the road, but they need to be much more productive than they are today. Today, they are standing like 20, 22 hours a day if they are private owned cars. That's not very reasonable to do this. So we calculated the number of passenger cars in Frankfurt, trucks, of municipal vehicles, and did an estimate of increased productivity the distance they have to travel throughout the day, the number of module changes, and the time that has to be reserved for maintenance, for checking the vehicles, and also for refueling them. And we came up with an estimate of we can lower the number of vehicles in a city like Frankfurt or comparable cities down to 20% of the number of vehicles as we have it today. So in numbers, for Frankfurt, we've got 520 something vehicles per inhabitant, per 1,000 inhabitants, and we can lower this to around about 100 vehicles per 1,000 inhabitants if such a fleet is doing all the jobs. And I have to emphasize, all the jobs would be done. So all people will be moved, all goods will be moved, and all road maintenance and greenkeeping works will be done. Nothing's left over and nothing's left behind. 20% of the vehicles.
That's impressive. Thank you, Jörg. There is one question about the technology. Do you need to mount specific hardware sensors for the load profiles? Rafael,
No.
maybe this is for you.
Yes. So we don't have to mount any additional hardware sensors to get load profiles from vehicles. That's why we call our sensors virtual sensors. So it's purely software based. There's no additional hardware required.
Thank you. A question about the CityBot technology. Are they running on battery, or how are they fueled? How are they powered?
So currently our prototypes are battery electric. That's basically due to cost for the very first stage, but it's a replacement for what we think will be required if we go into later on in serious production and into implementation in the city. We think the powertrain concept of choice should be a fuel cell, hydrogen-based fuel cell, because that gives you the most uptime throughout 24 hours or per week, if you like, compared to all other powertrain types. And that is what we need to make this system profitable and effective. The vehicles need to move around and accomplish jobs and fulfill orders, and not stand aside the road and do nothing. And the fuel cell concept is the most promising type of powering the vehicles in terms of uptime. It's not so much about travel distance, which can also be achieved by fuel cell powertrains. It's about traveling time, uptime, and being able to move around the city. We also have a side look, if you like, at battery-powered vehicles. That we wouldn't exclude that for certain applications, battery electric tractor modules might be the concept of choice, but we think mainstream should be hydrogen-based fuel cell.
Thank you. There's one more question about the implementation of virtual sensors for predictive maintenance. Rafael, can virtual sensors also be deployed on edge, or do they always rely on a cloud connection?
So yes, our virtual sensors can both be deployed on edge devices, so directly in the vehicle, or be deployed in the cloud. So both is possible.
Thank you very much. We would like to thank all participants for joining today, and also those who are going to watch our webinar as replay afterwards. Thank you, Jörg, for being our guest today.
Yes, thank you, Jörg.
It was a pleasure. Thank you for the invitation and for being part of your webinar series. Thank you. It was a pleasure.
And for all the participants, do not hesitate to reach out to us at contact@compredict.ai. Follow our LinkedIn channel. And well, if you contact us, we will put you in contact with Rafael or Jörg for further discussions. Please also note that we have the next webinar planned on 29th of March on the topic how to start and run a data science project in automotive R&D. Looking forward to seeing you.
Thank you. Bye-bye.
Okay. Thanks for watching. Bye-bye.